Okay, so to understand why delta H is not a good predictor of spontaneity, we have to go back to the definition of enthalpy. So enthalpy is delta H, and if we have a positive delta H value, so if we're adding 6 kilojoules for instance, this means we have to add heat into the system. Energy needs to be added. Versus if we say negative 6 kilojoules, that means that the system is producing heat. Heat is released. So if we look at heat alone and we try to decide if a process will be spontaneous or not, we would consider an exothermic reaction, a reaction that releases heat, to be spontaneous, whereas an endothermic reaction, something that adds heat or requires heat to be added, would be non-spontaneous if we're considering heat alone, because we need to add heat or heat energy into the system. Now, why this isn't a good predictor of spontaneity is because at room temperature, ice turns to water. Now, if we consider that just in terms of heat, delta H is positive, because in order to melt something like ice, you need to add heat. But that begs the question, why is this a spontaneous reaction? Why at room temperature does ice turn into liquid? So that's why we have to consider entropy as well. So we know that the delta G expression involves delta H and the T delta S. So where delta S is entropy, this is enthalpy, and this is temperature. So when we look at Gibbs energy, we know that a positive Gibbs energy indicates that it's non-spontaneous, just like a positive enthalpy value indicates non-spontaneous if we're only considering heat. But in this case, a Gibbs energy is a better predictor of spontaneity, because it considers entropy as well. Because in this case, when we're going from ice to water, while it is endothermic in that it needs heat to occur, what's really going on here is we're creating disorder. So the highly ordered ice, where everything is rigid, then becomes more free-flowing and disordered as it becomes water. And that plays a bigger role in calculating the delta G, and the delta G ultimately becomes negative because we have a positive 6 kilojoules, but then we're subtracting a temperature in kelvins, which is a fairly large multiplier if it was at 25 degrees Celsius, and then the delta S. And because the delta S is going more disordered, because it's becoming more disordered, that's positive. And since we're subtracting a positive number, our delta G ends up being negative. And a negative delta G means something is spontaneous.